I'm Simpong Lee. I will present the paper towards online multimodal social interaction understanding. It's accepted by the transaction on machine learning research in March 2026. I would like to thank all authors for their help and contribution for this work. Multimodal social interaction understanding (MSI) aims to interpret social behavior in multiple individual video. This ability is important for real-world human-AI interaction systems, like smart AI glasses and social robots. Recently, the following tasks are explored is to identify a speaker's referent among multiple participants using recorded dialogues and video streams. Speaking target identification aims to identify who the current speaker is talking to when the speaker says you and your. Pronoun coreference resolution focuses on resolving which participant a third-person pronoun refers to when the speaker says he, she, him, her, and his. Mention player prediction requires predicting which participant is referred by name when the participant name in the current utterance is masked. During the video and dialogue streams, a user can ask the system, which player is the speaker player 2 referring to? The existing MMSI studies can be categorized as offline MMSI, taking both past and future contexts as input. Since they rely on extended transcripts and video data, they produce responses with inherent delays. However, real-world AI assistants are expected to respond in real time, which motivates us to propose online MLSI that requires models using only historical information. However, online MLSI presents substantial and unique challenges compared to the traditional offline settings. As shown in the right-hand side, performance drops significantly when models shift from offline to online settings across 3 social tasks. First, online models lack access to delay and implicit cues, such as future transcripts or the reference responses. Traditional offline MMSI models rely on seeing the future social cues directly, making it not an ideal solution for real-time scenarios where such cues are unavailable. For example, in speaking target identification, after speaker says Brazil, and you saw village and werewolf when you were seer, right? The referent later replies, Player 1, yeah, village and werewolf. Offline models can leverage such useful future context to correctly identify Player 0 as the referent. In contrast, online models must rely solely on historical information, which may be ambiguous. Second, online models must rely entirely on immediate and past signals, where subtle social cues such as pointing gesture and posture, patterns, or body orientations become crucial for resolving reference. Since social scenes often involve multiple participants engaged in dynamic interactions, it's difficult to detect such subtle yet informative social signals from raw RGB video frames alone without explicit guidance. When prompted to describe the social interaction cues in the video, the VLM typically returns only coarse attributes, such as the relevant positions and appearances, using phrases like on the far right and shaved head and muscles, and occasionally produces hallucinations, such as incorrectly saying for people. To address these challenges, we introduced online MLSI VLM, a framework designed to respond to social tasks using only historical input. As illustrated, the model takes as input the user prompt, historical utterances, and video frames, and produces a real-time response under the online setting. To compensate the lack of future information and enhance the quality of historical signals, we propose two key components. First, multi-party conversation forecasting, which anticipates future dialogue trends. And second, socially aware visual prompting, which guides the model to attend to socially relevant visual cues. The first component is multi-party conversation forecasting. Cognitive studies suggest that humans improve online interpretation by anticipating upcoming social interactions. This motivates us to leverage multimodal large language models to anticipate future conversations to enrich social context. After answering the online MLSI task, the model generates the next few speaker labels and utterances. Although the predicted terms and wording may differ slightly from the ground truth, the model successfully produces plausible speakers and content that align with the surrounding context and human social reasoning. This helps the model build a more coherent understanding of the ongoing dialogue, while missing future context. The second component is socially aware visual prompting. We propose to enhance the representation of past video by using socially aware visual prompting, which employs off-the-shelf detectors to extract and highlight the positions, postures, and gestures of the participants. This facilitates the model to attentively interpret subtle and complex social interaction in the previous video. Here are VLM-generated description under different visual prompting settings. The result shows that using raw RGB frames, there's generic descriptions with limited reference to the social interaction. In contrast, when participants are annotated with bounding boxes and body key points, the VLM generates more accurate and detailed accounts of social dynamics, such as nodding and smiling and looking at the speaker. To enhance the VLM's performance on specific social tasks, we first construct instruction output pairs using existing social datasets. Incorporating future utterances from transcripts into 3 pairs, we then fine-tune the model via supervised learning with 2 objectives. First, task-specific objects. The model learns to produce correct answer for a specific online MLSI task. And second, forecasting objective. Model learns to anticipate future dialogues. The table presents the performance of our proposed online MLSI VLM framework with 2 VLM backbones, Queen 2.5 VL and Llama 3.2V, compared to a wide range of baselines on YouTube and Eagle 40 datasets. The result shows that our method achieves state-of-the-art performance with an average accuracy of 60.6% on YouTube and 56.1% on Eagle 4D, indicating its effectiveness on online MLSI. Here is an example of online MLSI VLM on speaking target identification.
See,
I didn't have to.
So you were the seer and you chose not to see anything.
It is your right, not your duty. You don't owe anyone at this table.
Just chose not to look at any guy. I just want to say, no one asked, but I was the robber.
Yeah, no one cares.
Okay.
What'd you rob?
At that moment, the user asker identified which player the speaker is talking to in the sentence of 2 masks. And then the machine can reply player 2 is the speaker target, along with the prediction of the future conversation. Here is an example of online MLSI VLM on pronoun co-reference resolution.
Yeah.
None of you switched any cards.
No.
Okay, so now it's like a trust thing.
It is.
I was right the first 2 times. You gonna trust me on a 3rd one?
No, because you're throwing out the trust card.
All right, That's cool.
So you were a seer.
Yeah. And I straight up looked at his card, and it was the werewolf card. So unless one of you guys switched it around.
I believe him.
Here is an example of online MS IBLM on mentioned player prediction.
The witch.
The witch,
It was
yes.
the witch.
Yes. Paul, what are you actually?
Okay. It's really fucking useless, but do you want to know what it is? It's funny.
Copycat into drunk?
Yeah.
Did you grab drunk?
Yeah.
Cheeky boy, I think you're a robber. I think you're a robber and you robbed from Mitchell. I think you're a robber and you robbed from Mitchell.
if
Which
you
is really
copycat
funny
into the
because I
drunk-
switched you.
Okay, the conclusion of the paper are, first, we propose a new problem, online multimodal social interaction understanding, which requires understanding based on historical information. Second, multi-party conversation forecasting helps online interpretation. Third, we need socially aware design visual prompting for understanding social scene. Fourth, we conduct extensive experiments on 3 interaction tasks on 2 social datasets, demonstrating the effectiveness of online MS IVLM. Thank you very much.